Okay, let's talk about recognizing a linear relation, like linear versus nonlinear. So how do we tell? So there's a whole bunch of different types of relationships out there. And we'll learn them in grade 10, 11, and 12. A whole bunch of different ones that aren't linear. So we want to be able to know if something's linear or not. So from a graph, it's pretty easy. We know that all linear relations, every single one of them, will always make a line. You don't even need to say straight line. As soon as you say the word line, it's just implied that it's a straight line. So this red line here, we can tell right away that it's linear because it's a line. And I can also tell this blue line here is a nonlinear function or a nonlinear relation. Sorry. So from a graph, it's really easy. Just see if it's a line or not a line. So we have a linear relation in red here, that's a line, and then this blue curve is nonlinear. So we can tell really easily from a graph if something's gonna be a linear relation or a nonlinear relation. Okay, but what about equations and tables? So let's take a look at this equation here, y equals 2x minus 1, and then let's take a look at this equation, y equals x squared. So if I do y equals 2x minus 1, let's say I make a table of that. I'll just throw in some values for x. So when x is 0, 2 times 0 minus 1 would be negative 1. When x is 1, 2 times 1 minus 1 would be 1. When x is 2, 2 times 2 minus 1 would be 3. And when x is 3, 2 times 3 minus 1 would be 5. So that's my table of values. So just from all the work we've been doing with linear relations, you should be able to tell that this equation right here is a linear one. This is a linear relation. It's in slope-intercept form. It looks just like all the other ones we've seen. And some really key things to point out here. There's an x and a y variable. There are no, we call this type of equation like a degree 1. It has like the highest exponent on the x variable is a 1. There's no like squared or cubed or anything. The highest exponent is a power of 1. And then from the table of values, we can see that the y values are increasing by 2 every time. But they're increasing by a constant amount. And we talked about this already. So that's like a constant. We called them first differences. In this case, it's also the slope too. So these guys are all the same. Okay, so that's how we can tell it's linear and nonlinear. And then if we look at the equation on the right here, y equals x squared, right away you can see this is a degree 2 equation, or a second degree equation. It is going to be nonlinear. This equation, it's a nonlinear relation. Because of that exponent of 2, that right away makes it not linear. And if we just plug in some x values, you can see from the table it won't be. So if x is 0, y would also be 0. If x is 1, 1 squared would be 1. If x is 2, 2 squared would be 4. If x is 3, 3 squared would be 9. So then if I check what are these guys going up by 1, going up by 3, from 4 to 9 it goes up by 5. So these are not constant. These first differences are not the same, making it a nonlinear relation. Yeah, so turns out anytime you stick something weird in an exponent, like an x to the power of 3, really anytime x is to the power of something that's not 1, it's nonlinear. Also, if you throw in something like a root, that's not going to be linear. If you put an x in the denominator, like 1 over x, that's not going to be linear. It's cool to have numbers in the denominator, like x over 4. That's going to be linear. Because really, that's just an equation with a slope of 1 over 4 and a y-intercept of 0. So that's fine. But you want to, anytime you see an exponent other than 1, it's nonlinear. Anytime you see this radical sign, nonlinear. An x in the denominator, nonlinear. What else? Oh, if the x is actually an exponent, like 2 to the power of x, that's going to be nonlinear. And all of these relations you'll learn about in high school. So these guys right here you'll learn about in grade 11. And this guy you'll learn about in grade 12. And this guy, x squared, you'll learn about in grade 10. So they're all different nonlinear relations, but you'll learn exactly what they are. Your job in grade 9 is just to identify if an equation is linear or nonlinear.